Hello viewers and my dear students. Welcome to session 12 on projection of solids demo. Here we have taken up projection of square prism with beta construction. This we have already started in the session 11 and we are continuing the same thing in session 12 also. Okay, actually please follow my different sessions under projection of solids to understand the subject. I have so many problems done under projection of solids, that is under pyramids, also under projection of prisms also. Okay, this is in fact problem number 21 in my notes, and under prisms it is actually problem number 3. Same problem I am helping you to do using solid edge. Okay. Now, as you know, we had done till this in the first session, that is session number 11. Okay. Now, the problem says it is resting on one of its base edges on HP with axis inclined at 45 degrees to HP. Okay. Now, what you have to do? You have to tilt right or tilt left. Whatever you do, it will be resting on base edge on HP. If you tilt right, it will be resting on C1 dash D1 dash on HP. If you tilt left, it will be resting on B1 dash A1 dash on HP. Okay. Now what I'll do is, first I'll go for the move command and I'll select the entire thing. I'll select the entire thing and see that this is on. Move copy is on. And I'll take the endpoint here and move it somewhere here. Okay. And I'll put escape. Okay. Now this has been copied, moved and copied. Now the problem says it should be resting on edge on HP with such that axis is inclined at 45 degrees to HP. Okay. That is why what I'll do is I'll use the rotate command now. Rotate command. I'll select the entire thing. I'll take one of the endpoints. This is a fixed point and this will be the moving point. I'll move it in such a way that it is inclined at 45 degrees to HP. Okay. Now you incline it at 45 degrees. Don't copy it. It is just only rotate. Okay. This should be off. Okay. Now once you do this, you see here this line, no, this line you extend it just for the showing the measurement. You go for parallel. Okay, let us say, see here, parallel is there. Okay, let us say you stop. Hello? In the trim command, extend to next is there. You do this and click on this, extend to next. That means it has come till that. Okay, now what you do now is see the dimensions. That is, mark the dimension. This axis should be inclined at 45 degrees to HP. Just see whether it is inclined at 45 degrees. Okay. Now it is inclined at 45 degrees to HP. It is proper now. Okay. It is proper now. It is 45 degrees to HP. Base edge on HP. Okay. Axis is inclined at 45 degrees to HP. And now we'll have in the usual way, take the line command. Take 0.13 only. Okay. Take the projectors down. Okay, take the projectors down. Okay, you take the projectors down here and take the projectors from here also. See that endpoint is sensed. Okay, you stop here only. Take the endpoint is sensed and stop here only. Okay, now once you do, the extra portion and all that you remove it off, because I told you already sensing endpoint is easier than sensing intersection point. Okay, this you do this. Okay, now as you are aware, when you are looking from the top, how it appears in the top view has to be drawn. Okay, now as you are aware, okay, on this you should get C and D, on this line you should get B and A, on this C1 D1, on this B1 A1. You can show also using this leader command also. Okay, leader command, you show that. And now you see here, I'll take the times New Roman 4 you have. Okay, now you see, you make everything ready. A, you make it ready. B, you make it ready. C, you make it ready. D, you make it ready. D, then A1, you make it ready. B1, you make it ready. C1, you make it ready. D1, you make it ready. Now, as you see here, see, on this you should get C and D, no? Okay. Now, you see here, on this you should get C. On this you should get D. Okay. In the same way, on this you should get A. On this you should get B. Okay. This is A, B, C, D. The top surface is over. Then, on this you should get C1. On this you should get D1. You make it ready. In a similar way, you take A1, put it here. This is on this you should get A1. Okay, on this you should get B1. Okay, on this you should get B1. Now, as you see here, I have always been telling you the step number 1 for any problem in projection of solids is get all the points and join the outer boundary of these points using dot lines only. Okay, first join the outer boundary of these points using dot lines. Now you see here, I'll join this. Intersection you got actually. Okay, that's good. Okay, then you join the outer boundary of these points. This is the first step. Now you should understand here carefully. See here, very important thing. You are managing 12 edges, 4 of the top edges, 4 top surface edges, 4 bottom surface edges. Okay, top surface 4 edges, bottom surface 4 edges, 2 vertical edges, 2 vertical, totally 4 vertical edges, totally amounting to 12 edges. Now you see here, how many edges have been completed already, you should know. Otherwise, you'll get confused. Now, just by the outer boundary, no, here you have 4 points. That means A, D, A1, D1. It's actually a rectangular surface. Okay, 4 points, rectangular surface. That means 4 edges already here. Even here, B1, C1, BC is already, as you see here, it is 4 edges here also. 4 here, 4 here, A1, B1, okay, and CD. In that way, 4 plus 4 plus 2, 10 edges are already over. Okay, then first step is over. 10 edges you already completed. First step, outer boundary. Second step, no, you please understand, while doing projection of pyramids, we are comparing apex with the base. If apex is nearer, remaining edges the base, you are making it dotted. If base is nearer, we are darkening the base. Okay, that is the second step in pyramids. Now, since top surface and bottom surface are same in projection of prisms, okay, top surface and bottom surface are same. Now you compare top surface with bottom surface. Whichever surface is nearer, darken it. Immediately, remaining edges of the other surface, make it dark dotted. That means here, when you're looking from the top here, when you're looking from the top perpendicular to HP, top surface is nearer, darken the top surface. Okay. Darken the top surface, and immediately, as I've told you, remaining edges of the other surface, that is in the A1, B1, C1, D1, the only one edge is remaining. This you make it dotted. Okay, dotted, you make it here. That first I have darkened it. Now you see here, I'll do this and go for this. Compulsorily you select this, you make it dotted. Okay, in that way, you have understood that that is how to get the 12 edges. Here 4 edges, here 4 edges, 8, 9, 10, 11, 12. In that way, you are able to complete 12 edges properly. Now, only thing what I have left out is drawing of an axis line. Okay, axis line will draw 0.13. Let it be first continuous. We'll do that carefully. Okay, from here. take from here, come down. From here also, you come down. Okay, you come down here. Okay, now as you are aware, axis should be on this line only. Okay, and as you know, the axis is only between here and here. I'll split this also. Okay, now you see here, axis is only between this and this. I'll show. I'll mark the points also. I'll see this here, O here, O1 here. In that way, you see here, this point is O. This point is O1. Okay, this point is O. This point is O1, and this is the axis. And show it as axis representation compulsorily this way, light. Okay, and that way you are able to complete clearly how to do the two stages. Now what exactly they told you is, okay, axis inclined at 45 degrees to HP, and it is inclined, the same axis is inclined at 30 degrees to VP. That means the true length of the axis should be inclined at 30 degrees to VP. Okay, but this is not in true length. Okay, true length of the axis should be inclined at 30 degrees to VP. It is a clearly beta construction because with reference to axis they have given, its axis is not only inclined at 45 degrees to HP, but 30 degrees to VP also. They have never said top of the axis inclined at 30 degrees to VP. They have said clearly axis inclined at 30 degrees to VP. When they said axis inclined at 30 degrees to VP, since axis is not in true length here, okay, we have to undergo beta construction here. That is why what I'll do now, here I'll take this, I'll make everything light now. Okay, I'll make one line here, sample line. From here, any point here. Okay, first I'll take 60, length is 60, angle is 30. Okay, get this line. This is the true length of the axis because 60 is the true length of the axis. Here, what you do, no? Here you do the locus line. Okay, here you do the locus line. Now this, click this. This is the locus line. Compulsorily you call this as the locus line. Okay, now you see this O to O1, no? You see here, I have got this as 30 degree. Actually, if you measure, this will be 30 degree. This will be 30 degree. That means this is the true length. Now you have to do one apparent cutting also here. This, if you observe here, this is the top of the axis, no? This measures 42.43. Okay, if you round it off, it is 43. Correct, no? 42.43. If you round it off, 43. That means with you have to take 43 mm, okay, 43 mm and cut on this line so that the beta is obtained. Okay, in that way you have to complete this problem. Anyway, we have come to the end of session 12. We'll continue this in session 13. Did you follow? We'll continue. Please refer session 13 to observe how exactly this problem is completed with beta construction. Okay. Thank you very much for watching. Thank you, friends. Thank you.